If vectors are non-parallel, by saying non-parallel, I mean that they have an angle between them. How are we supposed to find the resultant vector? Now, vector can be any vector quantity, which can be velocity, displacement, force, weight, or any other vector quantity. Let's say we are given two vectors and there's an angle between the two vectors. Let's say these are two forces of 2000 Newton and 2000 Newton, and there is a certain angle between them. Now we cannot simply add them up or subtract them up. We'll have to use the vector addition method of parallelogram or triangle. Here we learn how to use the parallelogram method. Let's take this example of this oil platform which is called Perdido. This oil platform is operated by Shell. It was moved out in this manner to its designated position where it was erected up. And it's huge. You can see that there's a helipad right here. This is huge. As you can see, there are two tugboats pulling this oil platform. Tugboat A and tugboat B. You cannot see their ropes because their ropes are submerged underwater. This is the rope of tugboat A and this is the rope of tugboat B. So how are we supposed to find in which direction will the oil platform move? Will it move in this direction, in this direction, in this direction, and with what force? You have to have these calculations ready before moving the platform to avoid some disastrous event. Moving on, let's try to solve this by using a parallelogram method. First of all, what you do is you draw a free body diagram. Now, a free body diagram is like this. You just make a simple diagram from the top view of the entire structure. This is our platform Perdido, and this is the boat A and boat B. Then you draw its angles. Let's say the angle of boat A with the horizontal, this is the horizontal line, is 15 degrees, and the angle of 2000 Newton with the horizontal line is 20 degrees. Horizontal line is directly at the center, or you can say it is at 90 degrees from the platform. It is basically a reference line from which you take the angles. First step is to set a scale. This is step 1. You set a scale. The scale I chose here is 1 centimeter representing 200 newtons. This is up to you. Set any scale you like, or set such a scale which you can easily draw. So here I set 1 centimeter equals to 200 Newton. So my line of this force will be 10 centimeter and line of this force will also be 10 centimeter. Then you draw a parallelogram. Step 2 is drawing a parallelogram. A parallelogram is a simple four-sided figure in which two of its opposite sides are parallel. It is drawn like this. This is my force A of tugboat A and this is my force B of tugboat B. So first I draw this portion of parallelogram, this portion right here, this portion. And this, the first thing I draw is the horizontal line, which is drawn in yellow. It is also represented as horizontal right here. I draw the horizontal line. From the horizontal line I take 20 degrees above and 15 degrees below. By taking 20 degrees above, I draw a line of 10 centimeter which represents my force of 2000 Newton which was of tugboat A. 15 degrees below, I draw a line of 10 centimeter which again represents a force of 2000 Newton which was of tugboat B. Then I complete the parallelogram. This line is parallel to this line, and this line is parallel to this line. The resultant of these two forces is given by the diagonal of this parallelogram. This diagonal is drawn in yellow. It is called the resultant. Resultant is basically the result effect of the two vectors. It is also called net force, or it is called resultant. It is basically the result of the two forces, or the result of the two vectors. So the diagonal of the parallelogram is the resultant force. Measure the length of the diagonal and its angle from the horizontal. Now this is the angle from the horizontal. By measuring the length of the diagonal, the length is 19.04 centimeter. I converted it into force because 1 centimeter gave me what? 1 centimeter was representing a force of 200 Newton. So these are my centimeters now. I'll multiply 200 by 19.04 to give me the force, which is 3814.8 newtons. The angle I measured is from the protector is 2.5 degrees. Try drawing this diagram on a piece of paper and you'll get the exact same answer. You'll have to use a ruler and a protector for this. This is a must. This is how you use a parallelogram method to find the resultant of non-parallel vectors.